Hello and welcome everyone. Welcome back to this installment of Python Live, powered by Amicus Recruitment and the Live series. For those of you who don't know who Amicus Recruitment are, we are a specialist IT recruitment agency that specialise in recruiting across three key areas of IT, which include Python, Golang and JavaScript. Now, my name's Jordan Hayward and I specialise in recruiting across the US with a specific focus on Python developers. And I'm your host for this evening. Today, I'm joined by David, a fellow Brit, who is a senior engineer at KnowledgeHound. David will be given a brilliant talk focused around going beyond the basics with Django. As ever, this is interactive, this webinar, and I encourage all of you to ask as many questions as you like throughout, and myself and David will get through them. You can do that by sticking them in the Q&A tab, which you'll find just at the bottom of your screen. So yeah, that's me. So let's begin. David, thanks for joining us.
Thank you. Let me go ahead and share my screen. Thanks for the introduction, Jordan.
No worries. Okay,
just to verify, Jordan, can you see my screen?
I can indeed.
Okay, great. So yeah, as Jordan indicated, this talk and webinar today is going to be about going beyond the basics with Django and how it interacts with databases. But before I go, I'd like to sort of give you a bit more background about me. So as Jordan said, I'm a senior software engineer at KnowledgeHound. I'm based in Chicago, USA, and I've been at KnowledgeHound for just over 5 years, and we build a data analytics platform for survey data, primarily using Python in the back end. So if you guys find yourself analyzing survey data, survey responses on a regular basis, then give us a call and we'll be able to help you out probably. Before joining KnowledgeHound, I spent 15 years developing in C, primarily at AT&T/Lucent /Alcatel Lucent. And then I spent a few years working with Ruby, and then I moved into the Python world. Recently, I've been dabbling with Kotlin as a sort of side interest, which is an interesting language, and that's built on sort of the Java ecosystem. So I've got a fairly good sort of breadth of knowledge on different languages. I was managing engineering teams for about 5 years, but I decided when I joined KnowledgeHound to step back down and return to being a hacker, being a software engineer and individual contributor. But obviously I do act as a team lead and still help with team lead type activities. So first of all, let's talk about what I'm calling basic usage of Django, because what this presentation is going to do is take us beyond that. And that will help you, understand a reference point for what I think is typical. And I'm using my experience at KnowledgeHound, learning Django, as the basis for this. The first couple of years, I was completely new to Python and Django, and I got a long way into building our systems and understanding the code base that was already here, using pretty much these patterns and these parts of various models in Django. So if you're using auto fields, integer or float fields, big integer fields, file fields, text fields, those are all the fairly typical standard field types that you would use to build a basic model in Django. And you can do a lot with just those field types. There are obviously others. When you're using a model.objects, then typical patterns to query the database and build your application code would be to filter on a field in a table, and perhaps you would do a filter, field 1 equals X, field 2 equals Y. Maybe you would want to filter and exclude fields of certain values. Maybe your models actually have relationships between them, so you have a foreign key between different tables in the database. So you might use an indirect relationship to query fields. So you pick rows from a model that uses a relationship of another model and another table. You're familiar with using get, all, iterator exists, and you sort of generally know what a query set is. If you've done Django for at least a year, you have at least a basic sense of what a query set is. And so that's what I'm calling the basic usage of Django. And what I'm going to do is try and take us a little beyond that, because you can build some great apps with just this basic knowledge. And probably the first 2 years of my time at KnowledgeHound, this is mostly what I used. But there's so much more that you can do with ease, and it will make your code a lot easier to maintain, a lot more readable, and it will just be more efficient. So let's dive into it. So first of all, let's talk about some of the most basic and simple patterns that you can improve on. So typically you use get, but what is often overlooked is that you can pass any expression that you pass to filter to the get method. So you can eliminate calls to filter in your code. So for example, if you have code or in an application that does a model object filter on a field, and then maybe you exclude another field, and then you do a get, you can invert this and you can just specify field1 equals X in the get. And so you can boil these 3 lines in your code down to 1. And it's a very basic example. One of the benefits here is when you're working in a shell, a Django shell, I highly recommend IPython. It makes it very usable to explore the data in your database. And it's very common that you might want to just filter and search the data that you have, and then it's often easier just to append a .get to the end of whatever previous command you were using to filter down, your data set. And so, you use filter until you figure out what expression you need to get the results you're looking for, and then you just recall the command and you append a .get. It's a bit of a lazy way of doing it, but when you're working in the shell and you're just exploring, it's a very quick and easy way to work. But again, this is a very simple pattern improvement. So let's go one step further. Let's leverage operators. And this is where, as you learn more about Django, you'll learn that you can query and filter data in the database with less specific matches. So using filter and exclude, as I did in the examples in the previous slide, you're doing exact matches, but quite often you don't know the exact values. If you have a table with strings, for example, you might only know the first few characters of a value in the database. Maybe they know they're at the end. Really good for matching on IDE. So you can do things like starts with and ends with and even contains. If you're doing a set of values, then you can use things like in to pass a list of values that you want to match on and just get those rows from the database. And if they're numeric values, then you can do greater than equal to, etc. And as you probably know, and this is probably reiterating some knowledge you have, but Django uses a double underscore notation to separate the field name from the operator. So in this example, the field1 underscore starts with foo is saying, give me any row in the matches where field1 starts with the word foo. Likewise, if you're doing field1 in any row that matches the values 1, 2, or 3. And this is how operators work. One of the great things about Django is when you're working with strings, if you want a case-insensitive comparison, quite often that can be sort of annoying when you first get into querying databases. But most operators in Django actually are prefixed with an I so that you can do a case-insensitive compare. So you can do an I exact or an I contains, and that will do a case-insensitive comparison. One of the most common mistakes I've seen in systems is people search a database based on an email, but they forget to use iExact because emails are actually not a case-sensitive string. They can be stored with capital letters. And so one of the big things to remember when you're like trying to match on an email address is to actually do an email _ iExact. And that will remove any concerns about case sensitivity with an email address in your database. This is somewhat basic to medium level knowledge. Maybe you know already, but let's really like take it to another level. When you're just querying on single values, then you can do everything we just talked about with in and contains, and you'll get, you know, a single value match. But you often want to query on multiple values in the database. And so how do you query for multiple values in different fields with, say, an OR operation? I want this field set to value, you know, X, or I want this other field set to value Y, and I want both rows from the database. And so as a most basic implementation, you might do something like, if your model.objects filter field 1 equals X exists, you find if it's there, you call your function to process that data. Then you do the same thing on field 2 equals Y. If there's data for field 2, then you process it. This works, and it'll get you a long way, but there are a number of inefficiencies with this. And Django will sort of point out that if you know you're going to use the data, using exists is an inefficient way of getting the data. And so what you can actually do is you can cast to a Boolean, and you'll leverage Django's built-in caching of the data. And so you can read more about how that works in this Django documentation that's referenced here. But let's talk about like how that works and how you can simplify it some more. And so by doing that, I want to talk a little bit more about OR operators. We all know logical OR. Like when you're using Python and writing Python code, you do, you know, X or Y in an if statement. But there's also a bitwise OR. And one of the most powerful things in Python is the built-in set capability, where you can use the OR operator to do a bitwise OR to merge two sets. So we have a couple of examples here. If you have a set with the value 1 and you OR it with a set of value 2, what Python will give you back is a single set containing both values 1 and 2. You can also do the same on an empty set, and then you'll get back a set with just 2. And so we can extend that same concept where you use an OR operator with Django Querysets. And once you start to think about how that might work, you can say, okay, I can call my function do stuff with a filtered set of data on field 1 equals X, and I can OR the results of that with model objects filter on field 2. And what I end up passing to do stuff is a single function call that has all the rows for values that are matching field 1 equals X or field 2 equals Y. And it's like, that's an improvement because now we've got a single, more functional approach in our code. It's a single line, it's more explicit, and it's easy to understand what's going to be processed in one step there. But let's simplify it even further. You can merge those two filters by actually combining the expression of each filter into a single filter command. And you do that by using a function called Q. Django provides this. It's a wrapper type function that allows you to wrap an expression, and you can use it with operators. So in this example, we're going to do exactly the same thing that we did in the previous slide, but we're going to say objects filter. So there's only one call to filter, but we're going to wrap each of the expressions, field 1 equals X and field 2 equals Y, in the Q function, and then use the OR operator. And what Django does here is it constructs a logical operation to join those two field values into the query, pass that through to SQL, and then you get in a single line with a single expressive value, the rows that match these two values. So it's a shorthand for calling filter twice. It's a little more readable. It's a little more explicit. And so you can get used to this sort of syntax. It takes a while to get used to, but after you start getting familiar with OR operators and how you can combine them with the Q method as a wrapper, it starts to become really, really second nature. The documentation is posted here, and there's some really good examples in the Django documentation for how to leverage this. So Django provides Q. There is another function which is called F. And it's like, okay, you're starting to think, why all these single letter methods in Django? As developers, we don't like to actually type a lot, right? So what the F function does is it lets you actually reference another field in a table. And then you can apply mathematical operations to that field, and you can filter on that value. So in the example here, I'm going to filter on column X, and I'm going to select and match on the values of X that are the values of Y divided by 2. So this is a very common sort of pattern where, oh, I only want to get the values of this field, the rows with this value, if it's a mathematical derivative of another field. And obviously dividing by 2 is a very basic example, but you can go to your heart's content with your complexity there. But what's great about the F function is, in the same way that filter will accept an expression that allows you to cross models and cross tables, F will also accept those same types of expression. So you can now do things like when X is less than F, and now we're going to use a relationship and we're going to cross from table A to table B, and we're going to get the field B from table A, and we're going to look and match only on the rows where field X is less than half the values of model A field B. So now as you start to sort of scale this up, you can start to do some really powerful things with crossing tables, building a query in a single line. It's easy to build this up in incremental steps in individual lines of code, but this is so much simpler. And then you can look at this and understand, okay, I'm really just filtering on the values of X that are half the values of B in table A. And so it's a lot simpler to write, and thus makes your code generally more maintainable. Want to make sure it's understood at this point that when you apply a mathematical operation on a field, this operation is being passed to the database. It's SQL and the database that's applying the mathematical operation. And because of that, it's going to be generally faster than if you try and do the same thing in Python. But that does mean you have a limitation in that you can't pass a Lambda or a Python method as part of that expression. It has to be something that the database is natively going to understand. So you have to think about more native operations like dividing by 2 with constants or literals. It's not something you can dynamically introduce Python data into that query. So that's Q and F. I'm going to stop here before we go too far and say, John, are there any questions that have popped up at this point?
Just the one at this point. You may have answered it already, but I'll ask it anyway. Is Q a function or a model class?
Yeah, so Q is a function that you import from the Django package, django.db.models. And so if I actually go back to the Q, you'll see that Django.db and you're importing Q, and it's just a function, and it's a function that wraps the whole Django expression implementation. I actually, to be honest, I don't know if it's truly a class. It could be a class, but I always think of it as just a function. So I hope that answers that question.
Yep, perfect. That's the only one we've got for now. So yeah.
Okay, cool. So yeah, moving on to values and values list. It's very common when you're querying the database with Django that you really only want to extract one or two fields from a table. And by default, Django will select all of the fields in a table. And you know, that's good when you are doing processing on small tables that you're going to use all the data. But in larger tables and larger models, you often don't want all of the columns, and it's just inefficient to extract all that data from the database. And you can use values and values list to get just the fields you want, and you know that your application code is going to use. So in this example, let's say we have a model that has two fields, name and city, amongst the many other fields it might have. Maybe it's got addresses and other things, but maybe you're only interested in the name and the city. And so you can call .values or .values list with name and city as the fields you're interested in. It's like Django will then create an SQL query that selects only those two fields. Then you start to wonder, okay, well, what's the difference between values and values list? So values returns a list of dicts, a list of dictionaries. Values list returns a list of tuples. So at first you're thinking about that and you're going, okay, why are both returning lists when only values list has list in the name? It's not probably what you first think when you read these function names, but it's a really interesting sort of mapping when you start to understand how they're working. So let's look at a couple of examples. So on the left here, I'm going to look at values, and I'm going to query name and city, and let's just pretend that this table, this model, has two rows, and it has name Dave, city Chicago, that's where I'm from, name Jane, city Florida. If you use values, you'll get a list of dictionaries, and you'll see the field name is the key, and the values are obviously the values for that row. If you use values list, what you get back is a list of tuples, and you'll see the names have been dropped and you've just got the values. So you get a tuple with Dave Chicago, and then you get a tuple Jane Florida. And at first, it's like, well, that's not terribly helpful. It's like tuples are sort of sometimes difficult to use because you have to index into them and what have you. But let's talk about why and how you might use these in useful ways. So Python has a good way to translate a list of tuples into a dictionary. And so one of the things you might want to do as an application is you might want to create a map from one field value to another. And what you can actually do is you can use values list to return a list of tuples, and then use Python's capability of casting that to a dict in an example like this, where you call dict to cast the iterable, and you pass it the values list, name, and city. And so what you end up coming back with is a dictionary that is indexed by name, and the value is the city that that person lives in. And so it's a very simple way, if you use values list, to leverage Python to get a name indexed dictionary. Obviously, it depends on how you're going to use the data as to whether you want to do this. But it's one use case where this becomes a very simple way of doing it. And it took me a while to sort of learn about this pattern, and then I realized how powerful it was. If you only need one value though, values list can be passed a flat equals true. So maybe you actually only want to get all the names. So in this example, you can do the same thing, and you can say values list flat equals true, and you'll end up with a list of just the names, Dave and Jane. So flat equals true is great when all you're dealing with is a single set of values. Now, one of the challenges with tuples in general is you have to use indexing, positional indexing, to access the data in a tuple. Well, one of the really good things in Python is named tuples. And so what you can do is you can eliminate that positional indexing and access the data through objects using their actual field names. And this example here, you import collections because named tuple is part of the collections package. And we're going to say we want field name and city. And so we're going to take the values from our tuples, name and city, and we're going to create objects that represent each row in the database that just have name and city. And then you can actually access the tuples by their name instead of positional indexing, which makes the code so much more readable. It's not unusual that people go down the road of using tuples and you start to do things like on the right here where you index into element 0 and then element 1, and it becomes difficult to evolve that code and maintain it. So you can use named tuples to actually get to a dot name. And you'll see here we have a list comprehension that just loops over all the values lists and constructs a new named tuple from the values. And this is a very simple way to convert a list of tuples into a set of objects that you can use through attribute names. The one thing I will caution though is you need to remember your overall application flow. Values and values list will create database queries for just those fields that you want. If you do that many times in your application because different parts of your application flow want different fields, you might be introducing more inefficiency than you expect. So just remember to look at your overall application flow and figure out if it makes sense to specify a broader set of fields that you want and rely on that rather than making lots of individual calls to values and values lists. Okay, before I go on to subqueries, I think there's a few more questions there, Jordan. So do you want to hit me up?
Yeah, so there's 4 in total. So question 1, any rule of thumb for when to use, in brackets regarding data size, values rather than get everything?
Yeah, there's no general rule. It really depends on the scale of your data and the scale of your databases and your instances for running your application. It's really going to be test it and try different sizes and look at the latency of the responses. And you can do a simple date time now around any methods and look at it. You will know your database models. If you know you're like using more than half of the data in a table, it's probably worth getting all of the data if you don't have millions and millions of rows. So you do have to come up with some judgment calls, and you can play with it yourself to figure out what the right thresholds are. So I wouldn't say there's a general rule, but I would be pragmatic about it.
Perfect. Question 2, when cast into a dict from values list, what happens if the tuple has more than 2 fields?
Well, because the values list you're saying actually is just the fields you specify. If you do cast it to a named dict that has more values, then I haven't actually tested this. I would imagine you're going to get a value error exception thrown because the named dict is not expecting that many fields. Now, it's possible with a named dict, you could probably specify a keyword arg that would capture any additional values, but I would have to like verify that and test that.
Perfect. Then question 3 of 4. Please tell how the dictionary will come out if we type cast a value list with more than 2 fields.
Yeah, so I think this is essentially the same question. If you end up with a mismatch between the named dictionary and the values list, you'll probably get an exception.
Okay, perfect. And then question 4, have you used data classes for handling value lists instead of named tuples?
Yeah, great question. I have not, only because we've been using the slightly older versions of Python, but we do want to get onto like Python 3.8 where data classes exist. And I think data classes are a great simplification for representing an object which is just pure data. And so I haven't played with that, but I think it's a very good idea to explore.
Perfect. That's the 4 questions at this point, so good to go.
Great. So yeah, let's move on to subqueries. When you start using Q and F, you can start to build up some fairly rich queries in your system. And Django is smart enough that if you actually pass and use the operators with another query set, for example, if you do a filter on name in, and then you use a different model's query set, internally Django will create a subquery that it can then use to extract the data you need. But sometimes you really just need to specify the subquery yourself. Maybe the subquery is complex enough that Django is not going to be able to construct that subquery for you. And one of the often patterns where you might want to do this is when 2 models are very loosely coupled. By allowing you to specify a subquery and build a more complex subquery yourself, you can actually do a lot more queries across loosely coupled tables than if you try and use a relationship, or if you try and actually pass 2 query sets together. Maybe the shape of the data doesn't quite fit. And so the subquery is just another wrapper function in a similar manner to F and Q that you can then use to actually build that subquery yourself and then pass it to a filter. Now, the one thing that you have to remember is anytime you're building a subquery, the result of that subquery needs to be like a single value, because you're going to be filtering on a value and using an operator, like in this case, name case insensitive contains, and then whatever your subquery is. So everything your subquery has to produce is a single value. There's lots and lots of ways you might use subqueries, but I would say generally this is for the most advanced sort of cases. I would try and explore using the existing query sets and capabilities in Django before you dive into trying to build that subquery yourself and use subquery. But it is a capability that's there. Subqueries were introduced in Django 1.11 along with lots of other improvements on expressions. And so this is a time when I'll say if you are on something earlier than 1.11, like it really would benefit you to upgrade to a newer version. KnowledgeHound recently went through an upgrade from 1 to 3, and we've fully upgraded our backend to Django 3 now, and we've already started using some of these types of capabilities in our backend. One last topic on expressions, annotations and aggregations. One common pattern in an application is you want to actually count the number of instances of a certain field value. And so you might, in a basic form, use something like a default dict, create a loop, which is using a filter and a values list on a single field. And then you simply increment the counter in the default dictionary starting at 0. And this would be a really, good way in just Python code to use Django's filter and values list mechanisms to do a sum. But Django provides a much better solution, and it pushes the responsibility onto the database. And so this is where you start to use the count and annotate methods. And so let's look at this. We're going to take a model, we're going to order the model on the table by name. We're going to take the values name, and we're going to create a new field called name count, and it's going to be the count of field name. When you first look at this, it's like, what the heck does that mean? It's not the most obvious. So let's break it down. If we do the same thing, then we can actually take the annotated value of a query, and the name count is going to result in a dictionary using the same trick that I explained earlier. If you cast to a dict and you're getting a values list of tuples, it's going to convert to a dict which is keyed by name, and then the value is going to be the sum of that name. And so you result in something like this, which is a count of Daves and a count of Jane. And of course, this is a basic example of two people in a table, so there's one of each. This becomes very sort of handy. If you know SQL's group by, that's what Django is using under the hood. And group by is actually simpler to use than this. So this is not the most easy thing to use, but it is really handy to learn. And so the reason it's also handy to learn is because what you need to understand is you're now taking data from the database and you're adding attributes to an existing object. So name count here becomes a new attribute on the objects returned by the Django query. And so if you look at the next example here, maybe you want to extract every value of a field called number and you want to multiply it by pi. This is what you can do. You can do an annotate dot new value, and new value will become a new attribute on the object that you can reference by just saying dot new value. And you'll get whatever the field number is multiplied by pi. And so annotate is a good way to create derived data of the data that's in your database. That's most of the hardcore like expression querying type things I wanted to cover, but I did want to cover a few other points. Managers are a concept in Django that simplifies the way you access data in the database. One common pattern when you first get started with Django is if you want to add some helper accessors, then you might create a class method on a model, something like filter by thang, and it returns you the class.objects.filter field1 equals thang. And this gets you a long way. But what you might want to do, and it's actually easier than your first thing, is you can create your own custom manager, and you can replace the .objects, which you use all the time, with your own .objects. And we're going to use object-oriented programming to inherit from Django. So we get all of the existing behavior of objects, plus we can add our own custom accessors. And the benefit here is that these custom accessors get separated from the model. So you're separating your data access from the business logic that might exist in your model. And so your code gets a bit more manageable because your code is just better structured. I highly recommend doing it. It took me a long time to appreciate managers. And when I realized how simple it was, it's a super valuable thing to learn. And you'll see in your model, you just say objects equals your manager. You define your manager and whatever your accesses are. You can actually use managers in lots of different ways to create different actual default behavior by overriding the get query set method. But that's starting to get into more advanced topics than we have time for today. So one last thing, the big scary issue in Django is managing your database schema and migrations. So why would you ever want to edit a migration? I mean, they're generated files. Generally, it's best practice in a system, don't ever edit a generated file, because if it gets regenerated, it might be overwritten. The good thing about Django migrations is every migration that's created gets its own new ID, so you never regenerate a new file. And so it's like, okay, maybe it's safe to edit a migration because it will never get regenerated, but why would I want to do that? The reasons you might want to do it is to handle different database adapter differences. If your tests are using SQLite, but you're using Postgres in production, maybe you need to edit the migrations to account for differences in the capabilities of the database you're using. Another thing might be if you're renaming tables or fields. Every time you run tests, all your migrations will run on that test run. And over time, your application can build up a lot of migrations, and you're just starting to waste processing time every run tests. So you can actually consolidate your migrations down and edit them to not create the old field and then rename it to a new name. What you can do is you can edit the migrations to just eliminate the old name altogether. And then when you run tests, it would just get the new name. It's like another use case is if you remove an old package from a system, like you would have to remove any reference from migrations to do it. But okay, if I edit a migration, won't that break existing databases? Well, the good thing is no, because the existing databases have already run the migration and they track the IDs that have been executed, then it knows which ones to rerun in the future. The important point here is you want to make sure you never delete the migration, right? If you actually replace the content with empty, then that's a better solution because you won't break the state management of existing databases that use and track the IDs that have already been executed on that database. But when you run tests, it would run all your current migration files. So, the key thing here is if you do edit your migrations, make sure your new end state after you've edited them is exactly the same as it was before you edited them. And that's one advice. I know time is getting on here. I have a couple of bonus slides here for you. One of the things you often want to do, I'll just run through these quickly and then we'll get into further Q&A, is if you want to look at the actual SQL that's generated by Django, then when you're in the debug environment, in your dev environment, what you can do is you can import the connection class, and you can actually list all the queries. So if you import a connection and then you do connection.queries, you can use slicing to get the last 10 queries. And so you'll get something like this, a list with a dictionary, which is a key of SQL containing the SQL that was actually executed, and really handily the time that it took to run. And so then you can start to do some analysis on, okay, and understanding what Django's doing to actually create the queries that the database are running. And you can start to look at the time that they take to run. And then one last thing, as we upgraded to Django 3, we already had JSON fields. It's important to note that there were old packages out there that supported JSON fields in the database, but they generally handle things only as text. What we did is we actually replaced those with the native new Django JSON field, and we had to make no other changes other than the references. And it was a very safe migration over. And I just wanted to share that. I can get into more details, later if needed. Recommended reading, the Django references here are all for the parts of the talk that I've given. And then these slides will be available on the KnowledgeHound blog as well. So I'm happy to open it up to Q&A. I will say, I have a 3-year-old puppy that was barking throughout this presentation. So if you didn't hear her bark, it's because I use noise cancelling software called crisp.ai. They're not a sponsor or anything. I just love the product. And as you will have found, you didn't hear her bark once during this presentation. So other questions, Jordan?
Yeah, that's great. I didn't hear the dog at all. So I thought you were just going to say how well behaved the puppy is, but but yeah, we've got 3 final questions, unless any more come in while we're going through them. But the first, please share your experience with prefetch related function. I find it really difficult to understand. Also, its efficiencies and inefficiencies.
Yeah, great question. So I've had the same experience. Every time I have gone to use it and I think, oh, it's gonna like yield a great improvement in our database access or our processing. I've been sort of disappointed in its use, and I end up not moving forward with it. You know, I have yet to actually find a case where it really is beneficial. Obviously, they are there. Lots of people are using it to great benefit, but I have to admit, right, I've not actually found it terribly useful. It might literally just be our data is not big enough to justify it. And so I think that might be an area to sort of investigate. And I'll be happy to connect offline and explore that more, because it is something I would love to learn more about, and why and what the use cases are for it.
Perfect. And then question 2, when working with a few other developers, what's the best way to deal with migration conflicts in Django?
Yeah, so you know, if you're getting a lot of conflicts with migration files, the biggest case I've seen that is if you're both adding new fields, for example, and then you both create a migration with the same ID. And that's a fairly common pattern. It really comes down to who's gonna merge first. And I would actually just go ahead, rename the file, and then edit the file to make sure that the dependency is on the other developer's file name. You know, you can just delete the file and rerun make migrations. That's sort of the easy way, but you can also just edit the migration. And it really is up to you as to which way you go. I haven't seen too many other types of conflicts that occur on a regular basis. If for some reason you've got 2 developers that are trying to actually modify the same field, for example, I think the only answer there is you need to sort of sit down with those 2 developers and figure out what the deployment plan is and what you're both trying to achieve, because maybe that's actually a sign that there's a common problem that you're trying to solve.
Perfect. Next one, any notes on querying into JSON fields? Querying deep into JSON is quite awesome and means never needing to use Mongo.
Yeah, absolutely. So this is something that we haven't used extensively in our production environment, but we've been using JSON fields to store quite a lot of stateful data. And we've tinkered around with querying the JSON, and it's something that we're going to do a lot more in the future. So I don't have any notes at this time on like how to do that, but the documentation for like Postgres support of JSON fields is pretty decent. And there are some good online tutorials for how to do that in the Django docs for the native JSON field. I will say my gut tells me if you have deeply nested JSON, it might get more cumbersome than you feel. And then it's like, okay, is it the right application pattern to be trying to query deeply nested JSON? And that's something that's sort of in the back of my head, and something that as we play with it, I will certainly be considering. So that's something for you to think about. But I would definitely say play with it and, you know, share your experiences.
Brilliant. And next one, do you know if there are any cases you don't advise to use values and values list?
The only one I'll just sort of reiterate is it is easy to overuse them, and you'll end up creating multiple database queries when it's better to just do one large query and rely on the query set caching. But to do that, you really need to look at like the overall flow in that path of your code. Like, one of the ways this often gets introduced is if you have two smaller methods, each of which call value and values list independently. But when you step back and look at the calling function, you find, oh, maybe a better application workflow would be to generate the query up front with all the fields and then pass the query set into each of those functions. Makes the code a little bit more complex because you obviously have to pass a query set around, but it will reduce the number of queries you're making on the database. So that's where just be aware of like your overall application flow. Other than that, I can't think of a time where it doesn't make sense to use values or values list.
Brilliant. Next one. How much migrations is too much migrations? Is there a way to build an intuition about, hey, it's time to trim them?
Yeah, that's a good question. So one of our biggest services has in the region of 60 or 70 migrations. And I'm at the point now where I'm like, I don't like to think every time we're running migrations that we're running that many migrations every time, especially since I know we've renamed fields and tables, and all we're doing is wasting time creating fields with one name and then renaming it, and it's just inefficient. So the real answer is the performance of your system is really the key. If it feels like you're getting slowed down, then I would take a look at it. If you have a sort of a principled gut feel that maybe it's too much, and like in our case, I'm already thinking that I want to edit some of our migrations to get it down. If you have that gut feeling it's too much, then I would say it's time to take a look at it. Unfortunately, there's no hard numbers, of course. Every system is different. Every system performs differently. But when you get to 60 or 70, I would start to think about, are there redundancies in those migrations that you can eliminate?
Perfect. And the next one, I think this question isn't related to today's topic, or maybe it is. Think about a scenario. We have a table having many data, and now we have to add a new unique required field. How can we handle this situation? Yeah,
so that's a pretty big topic. But Django does a really nice job where if you actually add a new unique together field to the model, the key is what are the default values for all of the existing rows in your database. And so if you look at like how you set a default value on the field, you'll find that you can specify that. You can also edit the migrations to do forwards and backwards migrations to manipulate the data and make sure that the old schema you're using is evolved into the new schema where uniqueness can be maintained. You have to write a forwards function to set the data for all the existing rows so that there's no unique constraint issues, and then you can move forward. And that's all possible in the migrations. So I would encourage you to look at how forwards func works and allows you to change data in the middle of a migration.
Brilliant. Next question. What's the next huge thing with Django, in brackets you did not cover here, that you advise us to look at?
Yeah, so I admit I have not spent a huge amount of time looking at Django 4. At KnowledgeHound, we tend to focus on the latest long-term support releases, which is why we've got onto Django 3.2. But I know in Django 4, Django 4.1, there's a number of new features that I've looked at, which right now I'm forgetting what they are. But if you look at the release notes, there's some very good features that actually simplify how to use it. And one of the things that does come to mind is they've introduced a lot of methods that will increase the asynchronous capabilities of Django. So they've been prefixing a bunch of the methods with an A so that you can get an asynchronous execution of that method. And I know that's, I think it might be Django 4.1 where that's been introduced. And I think as you get into a more, highly parallel application and start leveraging more asynchronous behavior, like that's going to be super valuable. It purely depends on your application design, and if you really have a need to do, lots of sort of parallel processing or parallel queries.
Brilliant. Next one. Have you ever used a custom middleware? I could not find a detailed example on the internet.
Yeah, so we do actually use a custom middleware. KnowledgeHound, we have a middleware that all our backend services uses as part of our authentication process. So every service validates the token that is used to validate the request. If you share your contact details with Jordan, I can make sure that we connect, and I'll be happy to help you learn how to implement a middleware. There's a lot of value to having a middleware. So reach out, share your details, and I'll reach out to you.
Brilliant. And then there's just a couple more. Answer to table with new required field is make that required field with null equals true. So,
well, you can say null equals true. That's one way. Or you can specify the default value. And this is one of those trade-offs. Sometimes the easy answer is to say null equals true, but sometimes you just don't really want null values in your database. And so it is one of those trade-offs for sure. But that is another solution, yes.
Perfect. And then we've got one final question. Was there any situation where you had write raw SQL queries instead of Django ORM?
Yeah, so this is where we get into an area that is sort of disappointing, to me, because we've had to write raw SQL a couple of times, and most of the reason that we did that at the time was not long after I joined KnowledgeHound, and we were back on Django 1.8. I will say that if we'd had the subquery support, we wouldn't have had to write those raw SQL queries. And so a lot of, I think, the need has gone away. But of course, it's a big domain. There's always reasons where you might want to do it. And the Django does make it easy to write raw SQL. For me, generally, I avoid it. I do my utmost to find another solution than writing a raw SQL query, because at that point it's okay, are we gaining any value from Django? So I generally avoid it. I will say, in the one case where we actually were really pushed in that direction, we actually decided to introduce SQL Alchemy, and we actually had SQL Alchemy coexist with Django so that we could do those more complex queries that we couldn't construct back in Django 1.8. If I were building that today, I would just do it all in Django. I would not introduce SQL Alchemy. But at the time, it was the best solution that we had.
Perfect. So I think that pretty much wraps up the questions, which wraps up the event itself. So yeah, massive thank you, David. I know you've had a pretty hectic couple of weeks with your big migration, and then obviously a bit of time off as well. So I really do appreciate your time for putting that presentation together, and then obviously presenting it today. So yeah, thanks for that. As well, massive thank you to the audience as ever. There were a lot of questions that came in there. I've actually just noticed a couple more. Oh no, they're not questions, they're just massive thank yous. So yeah, great event, and yeah, thank you for everyone for participating. This session has been recorded. It will be on our YouTube channel over the next week, so if you wanted to rewatch it, share it with anyone you know, feel free to do so. And also, if you did want to stay in the loop about our future events, then please do follow our events LinkedIn page, which is the live series, or Amicus Recruitment in general. But yeah, again, massive thank you, David, for today's presentation. Really appreciate it, and I hope to have you back on soon.
Yeah, will do. Okay.
All right. Thank you.
Bye, everybody.
Bye. Bye.